Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on factorizing quadratic binomials. So remember, we went through expanding last time. That's when you start with brackets and you end up with something without brackets. This time we're going the opposite way. We start off with something that has no brackets. We end up with brackets. What we're doing is writing an expression like this as something times something. That's what it means to factorize something. Write it as something times something. So we're looking at quadratic binomials. So quadratic means there'll be an x squared term. Binomial means two terms. This has 1, 2 terms. So it turns out that there are two methods for factorizing quadratic binomials. Sometimes you'll use one, sometimes you'll use both. So the two methods we use are HCF, highest common factor, and DOT's difference of two squares. So we use highest common factor whenever there is a common factor. So always try that one first. So let's look at some examples of highest common factor. So x squared plus 4x is an example of a quadratic binomial for which we would use highest common factor. So this is a quadratic because of the x squared term, and binomial because it's got two terms, x squared and 4x. So these terms have a common factor, and that's why we use the highest common factor method. So what we do is we write the highest common factor outside the bracket. So the highest common factor is x. So then in the brackets we say, okay, what do I times by x to get x squared? Well, that's just x. Then what do I times by x to get positive 4x, the second term? Well, that's positive 4. And then I'm done. This is factorized because I've written it as something times something. If I expand this, so I distribute the x to the x and the 4, then I would get back what I started with originally. So we're done. Let's look at another example. So let's try this one. 3x squared plus 9x. 1, 2 terms. Both of them have a common factor. So this time, they have a common factor of x again, but 3 and 9 also have a common factor of 3. So the highest common factor this time is 3x. So what do I times by 3x to get 3x squared? What do I times by 3x to get 9x? And then I'm done. Once again, if I expand these brackets here, then I end up with what I started with. So 12x squared minus 28x. Highest common factor of 12 and 28 is 4. And they also have a common factor of x. So what do I times by 4x to get 12x? I need to times by 3 to get to 12. And I need to times by x to get to x squared. So what do I times by 4x to get now not positive but negative 28x? And the answer is minus 7. So I need to put a minus 7 there. And I'm done. Minus x squared minus 6x. So this time I'm going to take out a factor of minus x. So then I times minus x by x to get negative x squared, and I times it by positive 6 to get negative 6x, and then I'm done. So let's look at some examples involving difference of two squares. So they are examples like this one here. If I want to factorize x squared minus 16, I know what the answer will be, but I'm essentially just reversing the process of FOIL. So this is difference of two squares because it's a perfect square minus a perfect square. That's what it means by difference of two squares. So what I do is I set up two brackets, I square root the first and put it in both brackets. I square root the second and put it in both brackets. One gets a plus, one gets a minus. So that's because when I expand this using FOIL, I will get that. There will be no middle term. It cancels out. So x squared minus 81 is a perfect square minus a perfect square. It's the difference of two squares. So note again, x squared and 81 do not have a common factor, so I can't take out a common factor. So what I'm going to do is set up my two brackets, square root the first, square root of x squared is x, square root of 81 is 9, one gets a minus, one gets a plus. So let's factorize 1 minus x squared. Difference of two squares, 1 is a perfect square, so 2 is x squared. So nothing different. I'm going to square root the first, square root the second. 1 gets a plus, and 1 gets a minus. So 9x squared minus 100. So 9x squared is a perfect square because 9's a perfect square and x squared's a perfect square. So the first term's a perfect square, 100's a perfect square, and I'm subtracting, so I'm going to use the difference of two squares. So square root the first, square root of 9 is 3, square root of x squared is x. So I've square rooted the first to get 3x, square root of 100 is 10, 1 gets a minus, 1 gets a plus. So let's look at this last example here. At first glance, it might look different to the others. It might not look like difference of two squares, but it most certainly is. This is a perfect square because it's something squared. 25 is a perfect square. So I'm going to set up my brackets just like I did before. Square root the first and square root the second. So the square root of this thing here is just x plus 2, because squaring undoes square rooting. So I'm going to write x plus 2 in each bracket. So then the square root of the second, square root of 25 is 5. 1 gets a plus, 1 gets a minus. So I'm just going to simplify this. Of course, 2 plus 5 is 7, and 2 minus 5 is minus 3. And then we're done. So let's just look at a few quick examples in which we will use both of these methods. So let's say I want to factorize 2x squared minus 8. So I have two terms here. Problem is 2 is not a perfect square and neither is 8. I can, however, use the highest common factor method. That's because 2 and 8 share a common factor. So remember HCF method? I write the highest common factor out the front. What do I times by 2 to get 2x squared? That's, of course, x squared. What do I times by 2 to get negative 8? And that's, of course, negative 4. So now what's inside the brackets is the difference of two squares. X squared is a perfect square, and so too is 4. So what I'm going to do is I'm going to leave my 2 where it is, and I'm going to factorize what's in the brackets. So to use difference of two squares, set up my brackets, square root the first, square root of 4 is 2, 1 gets a plus, 1 gets a minus, and then I'm done. So I've still factorized this, it's just now I've written it as the product of 1, 2, 3 factors. So always try highest common factor first. Sometimes you'll need to use both. So I just want to quickly point out that we can use these methods for most quadratic binomials, but there are some quadratic binomials that can't be factorized, and they look like this. So x squared plus 36. You might think it looks like the difference of two squares, because it's a square and another perfect square. But it's not the difference of two squares, because difference means subtract. This is actually the sum of two squares, and that can't be factorized. You can't use the difference of two squares method. So what about the highest common factor method? Well, x squared and 36 don't have any common factors, so you can't use that either. In fact, this one here cannot be factorized. You can't find two factors like this that will multiply, that you can use FOIL on to get x squared plus 36. So make sure you only use difference of two squares when it's a perfect square minus a perfect square. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.